Geological Society in America. We are so pleased that you're all here and so wonderfully pleased that Frank is here. Everyone who has heard him speak before, which I have not, has been so enthusiastic that I'm already enthusiastic myself. A couple of housekeeping things. We have refreshments, there's coffee, tea, and beverages in the cooler, water, and other things. So for this time or for lunch, if you brought your lunch, feel free to help yourself. There's a list posted on the door of nearby places to eat if you plan on going out for lunch. We have a couple of upcoming events. On October 21st, we're going to be working on excerpts from the work of the angels and man's astral body as part of coordinating with the National Conference and looking at the destiny of anthroposophy in America. And I thought I brought one up, but I didn't. The spring issue of Being Human on the back table here has those excerpts that they've been working from. So if you're interested in studying along, just pick up a copy of the spring Being Human. And then November 1st, we'll have our remembrance of All Souls, remembrance of the dead. So those are the upcoming events. And with that, I would ask Sept to please introduce his friend Frank Chester.
Hello. My name is Sept, and Frank and I met 14 years ago, almost to the day, about a month off, and we met at Rudolph Steiner College in Dennis Plotchek Security and what was then called Security Studies. And unbeknownst to us, Frank during that year was a busy bee working behind the scenes. And at the end of the year, he came to the class and presented this stuff that he had been doing the whole year, all quietly, in his own little San Francisco apartment. And it was amazing. And I don't know how many of you are familiar with his work, probably many of you have seen his website, but basically what started it was a question about the number 7 and whether or not there was a Platonic form that had 7 sides. And you probably all know Platonic form is a form that has the volume, that has polygons that are regular like squares or hexagons, or well, actually not hexagons, that tile in a way that encloses space such that it's equal on every side is the same as every other side. And there's only 5 of them, and actually Frank didn't know that when he asked this question, which is a good thing, because if he had known that, he would not have gone and found what he found, which is an equal area form that has 7 sides, but there are 2 different shapes. And you can't actually tell because that's spun, but there you'll see it many times. So this form is called the Chestahedron, and it was really exciting because this is a form that had never been around before. He discovered it and found out that it had a whole bunch of interesting properties. And essentially for the last 14 years, Frank has been just trying to find out what this form is, what it's about, what it implies, what it can connect to, and has been taken him as farther than he ever would have expected into realms about the geometry of the earth, about art, architecture, sculpture, and probably most importantly, the human heart, the form of the human heart. And that will be, I think, the subject of this lecture primarily is the heart. So in that time, he's gone around the world. He's demonstrated various things in the Philippines. He was asked to give a lecture and was given a chance to test some of his ideas in a sort of scientific way with this Chesta vortex organizer, which is a way of counter-rotating things using vortices to, like biodynamic preparations, things like that. He was a visiting researcher in residency at the Threefold Educational Center in 2010. He was asked to come and give a presentation at Dornoch, and Dornoch ended up buying one of his sculptures. And then in the States, he's done all over, and he was recently at Rhode Island School of Design, where he gave a couple presentations, great success, and RISD actually ended up purchasing a form from him as well. So on the one hand, you have sort of the esoteric institution of door knocking anthroposophy, and on the other hand, a completely exoteric institution like RISD, design school in architecture and design, both having this form, which is very strange, because that's not the kind of normal distribution that you would get for a single individual. And Frank's work is very transdisciplinary in the way that it connects across many ways of knowing in many disciplines, but with integrated principles, which he's going to talk about, I think, more in the second lecture. So he's been doing that nonstop, essentially. That's what he does. And he has just been doing all of that out of his little San Francisco apartment. And if you're interested in helping support his work, he does sell his sculptures, a set of sculptures, and has prints as well. And I think this is somewhere, this little thing, but you can see and hear some of the amazing work that he has done. And even better now, if you would like to get one of these by virtue of tax-deductible contribution, you can go donate through arteverywhere.org, and you can, there's like certain donation levels, and you basically get the sculpture instead of like a tote bag in the yard. That's better. You don't often get art tax-deductible. So I think that's about it. And the last thing is that today is a special event because we are just now available the first book on Frank Chester, which I happen to write and design. And this is like a test print. This is a slightly earlier version, so we actually changed the title, and the cover is a little different. And we added some introductions from some people and whatnot. But I'll have this, you can see through. It really showcases Frank's work. Just a lot of pictures, a little bit of text. And it's basically just meant to get Frank's work out into the public. So this book, I have a little card. Just has the website where you can go and you can purchase the book. It's kind of expensive because it's a really high quality book, like linen and papers and photo quality and whatever. So it's like $50, which I think was a lot for a book. But I literally I would make $1.75 on every copy, so that's basically the printing cost. But I do have the ebook available that's cheaper if you want to see a digital copy. And it actually looks pretty nice in the PDF. So yeah, I'll have these, I guess, back there for you to peruse at the break and afterwards. And did I forget anything?
Will there be a CD available on this presentation after the fact?
We'll probably put the video up on his website at some point. It'll take some time, but that's likely. So with that, I introduce Frank Chester.
Can I have one of those books?
Oh yeah.
Thank you for inviting me here. I appreciate it because this is the only way that it can go out into the world. And that's, I think, what we have to do in anthroposophy is to bring what we find. That'll bring people into what we're doing. I want to thank Sept for the introduction and Valerie for allowing me to stay at her house. Sept has done all my website. If you look at my website, I get compliments on it internationally on how well it's done. He's done it all, okay, for free. And then in the year of 2000, I discovered this form, January. And Sept was there in Fair Oaks with me, and he said he wanted to write a book. And I said, well, go ahead. So he said, well, I'm not ready. I said, okay. So 14 years later, he's ready. He wrote this.
I'm slow.
And this is all of what he put together. Now, when you read it, you're going to realize that he understands an awful lot about my work. Okay, and you will too after you read it, because it's been written by Sept, not me. Probably better. So, anyway, it's an expensive book, and Sept told you why. I think his profits are like $4 or $5. Okay? So it's mainly for the printing. So anyway, I mean, all the things that he said about me, I mean, maybe it was time to go home. There's not much more to say. Except to tell you basically what I'm going to do. First, I'm going to show you, I'll give a summary of what I'm going to do today, and then which I'm starting, and then I'll give you some background on how all this came about, and also I will put a little geometry up here, and then I'll start into more and more deeply into the heart. And okay, so I'll start off by saying that my intent was that after I saw that seal over there, the Saturn seal, which is the middle one, the blue one, and after I saw the capital of the Grythianum, I decided that I would like to make a seven-sided form, because there isn't one at the Grythianum or anywhere in the books. That's like this one. There are other seven-sided forms, but this is unique. So I started with the idea of finding that only. I wanted to find a form. I didn't want to invent anything. Like if you want to make a better mousetrap or a better fishing reel, okay, then you go and research all the fishing reels, okay, and then you get a better one and you say, okay, this is a fishing reel. Well, that's not what happened to me. I found a form and I have no idea where it is or what it does or if it does anything. So I was completely open, okay, to what this is. I have no intent other than to find a form, a three-dimensional form. So when you start research, you don't have to have some, this great idea of changing the world. It could be something simple, like I did. It's 7 sides. I can't get any simpler than that. And the cube has 6. So the intent, okay, you have to remember, it has nothing to do with any of these things I've found about the heart, or about bells, or about vortex organizers, or vortexes. None of that came from my intention. No intent. Okay, so first off, when you have an idea was a seven-sided form. Okay, the next stage to try to find out what that idea can be, manifestation, you have to draw it. You have to make drawings. That's called geometry. And then after you make the drawings, you make it, and then it becomes manifested. Okay? So in between something coming into the world and an idea about something in the world is geometry. So all of these have to be drawn. All the tables, the chairs, everything have to be drawn first. You have an idea, though, of a chair. You have the drawing, and it's here. So I start out with an idea. And I needed geometry. Now I started this when I was 60 years old. And I had no idea that I had any idea about geometry. I didn't know about the platonic forms. Okay, of course I was an artist. I know how to draw and all those kind of things. But as far as the science part, nothing. So I started with sticks and mud. I took a seed and I put 7 sticks in it and put mud around it, and that's how I started. So then you have to realize that when you start a project, you don't have to be sophisticated. You know? I mean, a second grader could have done what I've done. Absolutely. So if you remember that you don't have to start out with this big idea. Okay, so every form has a function. Every form has a function. And every function has a form. Period. They have an umbrella. The form of the umbrella keeps the water off you. Okay? So the form has a function, and the function has a form. So simple. So this has a function. Now this right here, this has never been seen before, because this is a seven-sided form spinning that creates a bell. And these bells are now being, I have about 6 in the world already. And inside, which is the dual of this, which is a reversal. Spinning makes a beehive. There's people studying this form who are bees. There's about 8 of these out in the world from different beekeepers. So, you know, I didn't start out with the idea of bees, right? So that's the most important thing for you to realize. Okay, so I'll start out with simple geometry. Really simple. A circle. Now what's really neat about this is so elementary is that if I take the center of the circle, I'll do it on the board. If I take the center of a circle, right there, and I draw a line around it, I use a compass. Now I have a circle, and I have its center. So simple. If I take the center of that circle and I move it out to the periphery, now it's out, it's extreme. It's now not centered, it's peripheral. So then I draw another circle. There it is. That is the basic geometry. I cannot tell you how many times. Where it is, all over the world, all throughout the history of us being on this planet. Okay, so you see here, if I go from here to here, I get 6 spaces. I mean, this is amazing that you can do this with a compass. So there it is. And then this one is here. And this one is here. So simple. It's a hexagram. Okay. Now what is amazing about that is that this is known as 1. So have any ratio or proportion, you always have to have 2 numbers. 1. So if that's 1 from there to there, the distance from here to here, the distance of that red line is root 3. And root 3 is, oh, it's 1.732, it never ends. On the computer, if you go to the computer and ask the computer to give you the numbers of root 3, the computer stops at 1 million. Okay, the computer hasn't gone past the 1 million. Okay. But I just showed it to you perfectly. I showed you how to get it. You don't have to take a ruler. There it is, perfect. Now if I take and I draw a circle in here, like that. When in doubt, you just go freehand. And I can draw a circle. Now what's interesting about that circle is if I draw it here, I can also draw it here. Same size, I'll draw it. Same size circle. And then I can erase this one. As you know, it's the same. Now this is amazing geometry. If you take, and you can see it's not quite in the center, but if you take a triangle, equilateral triangle, and you draw a circle inside the equilateral triangle, you draw another one on the outside of the triangle, this drawing, this circle here is exactly half that size. Or this is half this size. So if this is 1, this is 2. That's amazing. This is twice the size of this one. Absolutely perfect. So if I, if I do this, yeah. Now that geometry I just showed you is the basis of my work and my findings, and it's so simple. It is just unbelievably simple. But this is known as a bezier. All right? And this is exactly the balance between two polarities. One polarity, the other polarity. The exact balance is right here of that circle. Exactly. All right, so if I make this a hexagon, remember how I did this first. Here's a hexagon, like this. Is that clear? Is that, you want me to draw that bigger, or can you see that? You can see it? It's a hexagram. Here it is here. Now, one thing neat about it is I can get the, here it is here, so forth. Okay, this distance from here to here, okay, are two equilateral triangles. See that? The two equilateral triangles? See them there? This is root 3. You follow me? That's root 3. This distance from here to here is 1. And this is 1, 1, 1, 1, 1. Everything's 1 except root 3. And of course root 3 is all over the place. I mean, it's here, goes all the way around. Okay. So what is so important about this root 3, as Rudolf Steiner calls this, formative forces. Root 3 is formative forces. Formative. So if I take this and I put it in here at the very center, I have this out at the very center of the, so it's at the very center like this. All I have to do is bring this up to here. I have a perfect cube. Formative forces. A perfect cube. Root 3. I mean, this is enough to go home. I mean, it's just outrageous. This is outrageous.
Will you collapse it again?
Is that again? Is it ready?
No. Okay. One of the things that I have to mention to you is that I have a lot of things to cover, and the only thing is that questions are so important to me because it teaches me what I didn't do, what I still need to do. So I really want questions, write them down or something, and do it that way so that I might answer the question, yeah, along the way, and also you might have a better question. Okay. End of that lecture, all right? All right, so I won't go through all the process of how I found the seven-sided form, but this is what it looks like if you haven't seen it before. That's a seven-sided form drawn. And it has 7 equal surfaces, it has 7 points and 7 faces. That's 12 edges. This also has 12 edges. And I can put that seven-sided form in here. And when I put it in there, it has to be at root 3. Oh, here it is, in the cube. And the red straw is root 3. And root 3 is the distance across the corners of the diagonal of the cube. And that is the seven-sided form in there. Okay, so this was an unbelievable discovery that I could be able to do this. Is because how you get a seven-sided form with 7 points into a form that has 6 faces, okay, and 8 corners. I mean, when they told me to try this, I thought, forget it. But it didn't take long. I figured out how to get it in there. So, I have to get this lined up right. Okay, so when I got that lined up, I wanted to find out where this form comes from. So what I did is I divided all the faces into 6. There's, into 4s. So there's 4 times 4 is 16. There's 16 squared. And I found out that the Chestahedron, and the reason I call it, I'll tell you later, but I found that it hit right there at the corner of one of the boxes. So I thought, well now, if that's really the case, remember I'm trying to find where this form is coming from. I thought if I take that over to here, there's going to be a different form. All I have to do is follow this line, which is root 2. So what I did is I went back from here to the middle of here to that corner. And then I went from the middle of this box to that corner. And I made all the forms and I brought them. So here they are. This shows the progression in a lawful way of what this form is at these different positions. So this is the midpoint of the square, and this one is the very edge, the corner. So I found out that if I'll make this bigger by going to this one, going from here to here, it became this one, and then all the way up to here, it became a tetrahedron. This form is coming from a tetrahedron. And it's going all the way down to this bottom one, which is this shape. And this shape is an octahedron. It's an octahedron with a tetrahedron on the bottom. That's what this is. Now that's amazing because this is known as a reversal. This is known as fire, and it started out with fire. It started out with this. And it's exactly half the size. Exactly half the size of a tetrahedron that I started out with. Notice this thing again here. This is half the size of this one. So, we'll put these back in. What's so amazing about this is, you see, all I have to do is turn it to the very center, and that'll move. So this is a discovery that I found. I still don't know what it is. What is this all about? I know this is air, which is reversals. I know this is this is fire, or warmth. So the rarefied one is warmth, the physical one is fire. The physical one of the octahedron is air, and the rarefied one is air. The rarefied one is warmth. Not warmth. Somebody help me out. I'm trying to remember. The physical. Which one?
Light.
What?
Light.
Light. That's right. Terrific. Thank you. The rarefied one is light, and this physical form is air. Okay. So these are just a little alchemy things, and I'm going to move on. Now, one of the things that I did was to try to find out where this is. I'm going through a process to try to tell you where this thing is coming from and where I found this. Okay? And of course, this one is the most important. Now, all of the things I've just shown you, including the forms and in the cube, okay, aren't there anymore. This is the geometry. This is the scaffolding that you have when you build a building. And when you're all done, you take the scaffolding away. You don't see the scaffolding anywhere. It's gone. But the form is there. So it's like this. So if you have some arches, they have to be scaffolded. Okay, and then when the scaffolding is gone, you have no idea of what happened here. Okay, and that's what I'm showing you here is the scaffolding. So it means that any organic form that you see, okay, represents a geometry behind it, whether you see it or not. So there's the scaffolding taken apart, and then of course these get more complex. They're gone. They were there. Okay. So I started out with platonic forms here, and I found out that this form, okay, was the tetrahedron. And these forms are really important. Like I said, there are only 5 of them, and the 7-sided form is not one of these. It is not a platonic form. So that's important for you to realize. So the next thing I did to try to find out where this was. Remember, I'm working and working all the time, and I want to tell you that behind all of this, there are so many failures. You know, you see all the successes, but there's so many failures before I got to this. But anyway, I put the form into edges only. Here's a 7-sided form with edges only. Here they are in the cube, which I showed. But let's see if this does what I want it to do. I think this one I have to be patient with. I'm not sure. But let's see if I can get this. It's not reversing. Well, I've lost it here somehow. Now I've gone into another area. So maybe, Steph, you can help me with this. Bring it back to where it was. And I'll tell you about this. Here's the form and edges only. So what you first saw was faces only. This is edges only. And so what I did is I tried to figure out what can I do to change this. Now it's too strong. I mean, you can't push it. You can't push it. How can I possibly change this? So that's also known as water. Okay, so I thought, well, what is water you do? It's probably is that I could change it by spinning it. And so I spun it and I turned it into a bell. And also, when I did that, I also got the 2 circles again. The same 2 circles I just drawn on a board. Look at them. And they're perfect. They're absolutely, one is twice as small as the other. Okay, so that's starting to give me a clue too.
This one you want it?
Yeah. Okay. Well, that's fine. So, now, see, it's gone. It's supposed to come in, and then it's supposed to go away, but it's gone away before I'm ready. So, I mean, that's really neat how it worked, huh? That's known as a reversal. Anyway, you have to go back to it.
It'll keep going back.
Yeah.
Here it comes.
So anyway, enough of that. You saw it here. But what happens is this is what happens. The tetrahedron goes like this. It's vortexes. This is how I found the form. It's a vortex. I knew that because in the cube it spins. So what happened was it starts as a tetrahedron, and it spins to an octahedron, and then it continues, and I continued it on, which is the drawing up there. It expanded into a tetrahedron. Can you imagine that? That it went from large to small to large. This is the missing link in Goethean science, in Goethe's theory. Goethe's theory is all about starting small, getting big in the middle, and getting small at the end. He never found the reversal of that. So this is the missing link of his science. And why? His was based on flowers or on plants. This is based on an organization or an organ. This is the transformation of an organ. Okay, so I made this bell, yeah? The spinning one. So what I found out was that at root 3 in the cube, if I put this right in front of me here like this, okay, I have found, you're right, yeah, I have found that this is the angle that the heart sits in the body. It sits in the body at root 3. Now, according to the textbooks and according to this research paper, it says the axis of the heart and the body vertically axis forms an angle of approximately 45 degrees. And all of the textbooks that I read, okay, on the heart, say that the heart sits in the body at 45 degrees. Well, in a way they're right, but they don't know geometry. So if it's 45 degrees this way, and I turn over here, it doesn't work. It becomes a plane. The heart sits in the human body in a three-dimensional axis. Now, if you look at the cube straight on, it's 45 degrees. That black line going right straight across the corner. Look. Isn't it? There it is. 45 degrees. Yeah, they're right. Now, if I turn the top here, it's also 45 degrees. Get this back in here. And from the top, it's also 45 degrees. All of you now know that that 45, 45, 45 is really root 3. So what it's saying is that the heart is sitting in the body at root 3. It's a balance. That reason that it sits at root 3 is a balance between forward and backwards, right and left, and above and below. Because this is the balance of it at root 3. So it's a three-dimensional balance. Okay. Now all these these are research papers that I have studied. I studied 50 of them. And I have a list of them if anybody's interested in. It tells you where I found them, how you can find them. I went on the internet. So I did textbooks first. Then I realized that all the textbooks were basically coming off papers. So I went to the papers, to the direct source. And I did 50 of them, and I found out that all of these relate. So anybody that's interested, I have copies of that. All right. Let me go on. So there it shows you the 45 degrees. See how 45 degrees is on the face, but really it's 36 or 35 plus. Not quite 36. So here it is. I went and got some x-rays, okay, of the front of the heart, the top of the heart, and the side of the heart. And you can see that they actually are 45 degrees. Now you know why that's not correct. So here it is in the heart. Here's the heart at 36 degrees. So I made a paper rib cage, and it's accurate because I did it after a paper model I found, and I made it three-dimensional. And the cube is in there, and you'll see that there's the heart right there. It's on this side of the body. Okay, and then here I'm showing the cube with the root 3. And then I also found this, so I have to go to art once in a while. I found this crucifixion sculpture that was from the 7th century in Spain, and this is the crucifixion, and there is the cube. How they know that? And you can see where there's a cube right there, blowing it up. So there's the top of it. And root 3 would be here. Okay, now first I showed you this. Okay, and when it spins it looks like this, and then when you make the bell it looks like that. So, because it was spinning, I saw that it was a vortex. So I thought, well, how am I going to work out a vortex? So I found out how to make a vortex generator, and I made it. I made it out of a spa pump, and so I went to the hardware store and got a bunch of plumbing and all that kind of stuff, and I made it. And This is the left ventricle vortex research. So this I have found is the left ventricle. So I wanted to put this into a vortex generator. So this is the vortex generator. I can control the vortex, not only in speed, size, I can decrease it. I can have control over the vortex. And this is what the machine looked like on my deck. So I have a pump down here, I have a valve here that I can adjust and so forth. And what I did is I put that little guy here, okay, in the vortex machine. And I found out that this tape follows the contour of the vortex. This is a vortex. And this part here of the vortex, okay, this is speeding up. The vortex is speeding up. This is slowing down. That's why it has that shape, because this part is slowing down, this is speeding up. So the heart is a balance between acceleration and deceleration. As far as the form has a function. Alright, so what I did is I thought, well, if this is really root 3, let's see what we can do with it. So I put the form in the vortex generator at root 3. And here it is. There's the vortex going here. And here's this at 36 degrees. There's a lot. And what happened was this form pushed the vortex off to the side. So I wanted to, so I started to study that, and I found out, okay, that this form right here is becoming the right ventricle. Not the left, but the right. And so what I did is I took this form and I kept adding epoxy here, waterproof epoxy, and so I was able to create this form around this one. And this is what it looks like. The blue one is the vortex that has been indented. This is a complete, perfect vortex, and so I put this guy in, and it pushes this vortex over on the side. So now we have a vortex trying to become like this one, but this won't let it. So it's pushing it over here. And what's so amazing about it is that this is the same size vortex as this one. And so I make a cross-section of what it looks like. So this volume here, okay, is approximately this volume. All right, so I have a picture here to show you that. That's what this ventricle is. Now, if you look down into the vortex, there it is. And it's spinning around like this, and it makes an eddy right here, and goes down to the point. But it doesn't get all the way down. It doesn't get all the way down. It stops right there. And there it is. There's that shape right there. That's how I filled it up. And of course, here's the one I'm showing you. And of course, if you look at the internet, you look at the heart without the atrium on the top, just the ventricles. Okay, we look like this. This is right off the science books. This is right on the textbooks and on the internet. You go on the internet, you'll see the same thing that I have here. This is a real heart, okay, at the section. Here are the drawings of that real heart. Remember that this is the scaffolding. This is the geometry behind it. Although, of course, you know that the heart is going to be different in configuration, but the basic geometry will be there, even though we have a variety of cross-sections of heart depending on the person. Okay, so this is what happens. People who study the heart, these cardiologists that are specializing in research, okay, they have to develop a tool to research. And what they have developed is they use magnets. Okay? So they use magnetic imaging. All right. And so what they do is they either tag, they put dyes, they do sections, they do the magnetic images and so forth to try to find out the phenomena of what's happening in the heart. I have nothing to do with that. Mine has what's behind the phenomena. What's the hidden part? Not what is the obvious thing about measuring. Now we need these measurements, and we need magnetic imaging. We need it. But now what I'm trying to do is not try to compete with any of these things. I am trying to show a new tool. Now if you have a toolbox, okay, and one of the wrenches doesn't work on all the bolts, okay, you don't have to use it, or you don't use it. If what I'm showing you, these new tools, if it doesn't work, that's fine, don't use it. But if it does, it's there for you to choose, to try, to find out. Is there anything about the original scaffolding of the geometry that really I can use in heart research? Because the magnetic images will show that the blood is swirling in one direction and hits the apex and goes out the aorta valve and so forth. But why? I can just say it does, and I can see how it does. Look, I see the phenomenon. There it is. Okay. That's not good enough. We need to know more what's behind the phenomenon. And that's where the geometry comes in. Okay, so here's what the geometry that the heart researchers use. They use this. They've taken geometry on the outside. And they put a net around it, and then as they watch this heart move, they watch the way these change here. Well, that's fine. No, that's okay. That's not my interest, but it's theirs. So, this is what I've done. I've tried to find out what's not only on the outside. Now, I've been criticized that, well, yeah, he's got this thing that looks like the heart, but that's not good enough just because it looks like a heart. Well, that person who said that, the doctor who said that, never went on to look at the rest of my research. He just looked at, he's got this thing that looks like the heart. Here it is. This is what it looks like in minimum surfaces. So what I do is if I blow a bubble in here, yeah, it looks like this. The seven-sided form, okay, but it's taking on a left ventricle shape. And I say, well, that's not good. Well, that doesn't have anything to do with the inside. Well, I was going to break. I said, the guy won't look. So I said, okay, so if you take the real heart, okay, here it is. Take the atrium valve. Of course, this is the mitral valve. This is the blood that comes in from the atrium that's coming from the lungs. It exits out here. So let's look at the geometry of that. You see the geometry? Look. It's the same thing. This circle is half the size of the outside of the heart. I mean, how else can I explain if this is really real than to try to do it this way? Okay, so like I said, minimum surface. I blew a bubble in a cube. And I also blew a bubble into this one. Okay, and it looks like that. Which is here, I've shown you. Okay, so compare this to the left ventricle in the heart. So I did. There's the left ventricle. And you can see that the guy says, yeah, the shape is fine. It looks pretty good. So what I did is put it in the vortex. Okay, I put it into my vortex generator. Now you see now it has become organic. It became organic through minimum surfaces, and that's what all forms are trying to do, is become spheres. Everything is trying to become a sphere. Well, our planets are all spheres. So, if I try to make this geometry into a sphere, this is how it looks. So I put it in here, and I found out that basically the geometry is showing, okay, in the vortex generator, that this is accelerating. Okay, and then I found out that when I turn the machine off, this is deaccelerating. This is a deaccelerating form. And it's deaccelerating twice as fast here as it is on the outside. This is deaccelerating. This is not an accelerated form. Okay, so if I went back to this again, okay, I'm showing this going from wide to small to wide. And this is the scaffolding that's behind it. Now, one of the really interesting things is this. If I can do this. All right. I think I have another one here that I have to get. I'm not sure. I had it standing up. Yeah, here it is. This is the one that's in here. So what I thought I would do is I saw this process of how this was working. I don't want to put it all back together because usually I can't get it back together very quick. But I'll just try real quick anyway. So that's right. I was lucky on that one. Then the other one is somewhere around here. Oh, here, of course. It's right in front of me. Well, this is the one I took out. It's supposed to be like this. see if I got this right. I do. I got it right. Now, am I okay? You see it? Is it right? Well, since nobody said anything, I better check it.
Yeah.
It's right. What I decided to do was I tried to take this one, which is the extreme, and put it in this one. So I took this one and put it into there. And there it is. There's the Chestahedron, the first one. And then this guy here is the other one that's at the other end. You see how I did that? Oh, easy? It works too, it fits. It's lawful, and it works. Now, so I put that in here. And then what did I do? Then I tried to twist it back into this one here. So I took this one and went like that. And here's how it looks. This is the second stage. Same two circles and everything. You can see it, that the other one's inside there. See how I left it open so you can see it? See it in there? Oh, there's a good shot of it. Now remember, it's being twisted in the cube. So not only is this one changing, but so is this one. This hasn't gotten to that kite shape that the original one is. And this one here is getting smaller compared to when we started out. Now it's smaller, it's not the same size. That is because it's spinning. It's spinning in the cube. This spins like that. Now if I continue to go on until I get the Chestahedron, it looks like this. That's the Chestahedron that I'm holding on the outside, and this one right here, okay, is the one that's also changing at the same time with the Chestahedron. And I found out that this form inside here is the inside of the left ventricle. And between the two are the muscles. This is the inside of the heart, this is the outside, geometrically. And it's all coming off the same thing that's going like this. It's vortexing. So here they are. Here's the first stage. Here's the first stage. Here's the second stage. And the third stage. Right there in front. So now we're getting to the inside of the heart. Alright, so this shows you basically what I did. I put the two together. Turns out like this. Then I decided to put both of these back into the cube. Edges only. What all this is faces only. Edges only. And I did. I put it back in. And here it is. Here's both of them together. Edges only. And one of the big things I wanted to do is to find out, see how I made everything lawful? It works just the same way. This is the form in the cube, exactly, lawfully. I thought, well now, how am I going to try to make this thing move? Because the heart moves, the geometry doesn't know how to do that. So I figured out how to do it, and then here's how it works. This is how it works. That's how the geometry works. But the only problem is that the inside of the heart is spinning. It moves in this direction, where the outside is basically moving in this direction. So I had to figure out, how do I make this spin? I got it both moving together, that's fine. But that's not correct, because this has to spin. This has to be like that. So the inside is moving like this, and the outside is moving like this. I have to do that both together. So let's see what I did here. I got it into the cube, okay, and then I made it this way. And then I found out that I found out how to do it. And here it is. It's the same form again, with the inside and the outside. Same one, bigger. And I found out that I can do this again. Look at that. But that's not right, is it? This somehow is going to have to spin. So how do you make that spin? So I wish I had a pair of pliers. I can't do it with my hand, so I have to force it here. But this is how it works. This part, okay, Okay. This part expands, and this part contracts. Now watch it contract. So it's spinning, it spins like this, goes back. Spins like this, goes back. Spins like this, goes back. And at the same time it's going like this. Right? You can see that that form is actually moving. So I found out the skeleton, the scaffolding of the original so-called design. Okay, so let me show you the inside of that ventricle. Here it is here. That's the inside. Now the problem is with this is that, see if I brought that with me. Let's see it. But that's the shape, okay, of the geometry inside the heart. But now here's the problem I had was this, was that these are the actual, this is a plaster of Paris put into a deer heart, hardened and brought out. And you can see that it has a spiral and it's shaped like this. And this is one, this is empty, there's no blood, this is filled. And notice I have a straight line here, and this end bends. Well, I don't know if I can go back. I mean, I can go back. See that? It's not like that. The geometry shows that it's like this. That I have a solution. The only problem is I didn't bring the actual form, but I can still show it to you. Well, maybe I can do it in my images. But that depends on how you take this form and photograph it or spin it. You see how one side is flat and the other side sticks out? That's because you have to just turn it a little bit. So now that form that you had before has exactly the configuration of the inside of the left ventricle. It's not like this, is it? It's not like this. It's like that, but if I twist it just like this, 30 degrees, then it looks like this. And here they are together with the heart. This is the shape here. This is the inside. This is this form and minimum surfaces. And that I might have brought. This is the inside. This is minimum surfaces of that form, of this form. This is minimum surfaces of this form. Just a lot like this, huh? Just blow a bubble. Okay. So that was really great. This is starting to show you that there is some kind of consistency in the geometry in relationship with the heart. And I put the geometry, I made the outside of the left ventricle of plastic, and then I put that one inside it to show you the thickness. All right, so then, as you see, this is the form, okay, and edges only, again, of this form. Let's see, I have a picture of that. And spinning. That's this spinning here. See that? That's this one. That's a photograph of the one I got on here. So this guy, okay, in this form goes all the way down to the very apex. This is called the apex, it's called the base. And this is the apex, and this form goes all the way down to the apex. And when I started doing the heart research, I saw that the inside geometry, architecture of the left ventricle never goes down to the bottom like that. It's always thick vocal down here. But that's inconsistent with my form. My form is saying that the inside of the left ventricle architecture goes to the apex. Okay. Just like this one does. So here we go. I am saying that the apex is paper thin. And the reason I know that is because I found two photographs that show it. But also there is one doctor that says that you can take your finger and you can put it in the bottom of the heart and you can push it right up to the apex and it's paper thin. He gives it, I think it's 3/32 thick. Paper thin. Now remember, if that's paper thin, okay, you got the blood coming in here like mad, okay, Why doesn't that blow out? It's paper thin. You know, you have pressure in an inner tube. I don't know if you know about that, but if there's a little opening in the tire iron, it pops right out. That's what should be happening. This should be ballooning out. But it isn't. It doesn't happen. So, I see somebody out trying to ask me questions. Please write it down. Oh my gosh, please. I want to answer. Okay, so, here's the thing here. Here is a picture of cross-section of the heart. Now, sure enough, the muscles go all the way down here, look. But these little crevices go all the way down to the end of the apex. So when you put your finger down there, you're going to go all the way down. So this is showing, okay, even though there's muscles around there, it does go all the way down. Here's another one. I really like this one because look, you can see why I like that one. Now this is the myofibers. These are the fibers that run around the outside of the heart between these two layers, between here and here. And they have a configuration, okay, that I studied a long time. Matter of fact, I put this drawing up in front of me for 2 years. And this is a dissection that a guy did. His name was Bell Pettigrew. And he was an English man who studied the heart in the 1850s. And what he did was he took the heart and he cut this right ventricle off and it just fell on the floor like a napkin because it's thin. But he's really interested in the main muscle. And what he did is he found that the fibers, okay, as he cut one other layer off, put it on the floor, with the cut. And also the second layer in is changing direction. Third layer he cut off. It seems to be tucking in here like that. And then I knew when I saw that the heart is a vortex that's wrapping inside each other. It's a cone. And then he kept going. Look, it's still going in here. But now it's horizontal. Look at that. And then eventually these myofibers, okay, go opposite direction. They change direction. Another balance between right and left. Nothing about the balance of the heart. So anyway, here's what I found is that here's the direction of change. Now he has 8 drawings here. And I found that there's a discrepancy between the different authors saying that there are 8 layers, and other ones say there are 7 layers. Yeah, okay. So, anyway, if this is a cone, I'm going to make a cone. So this is how you make a cone. Let me show you how I did it. If I take a plane, projective geometry, we always use lines like this. Okay. So I put them on there, like to do projective geometry. This is supposed to go, you know, this direction, then infinity, and this one, infinity, whatever. So what I did is I put a red line there, and I thought, okay, I'm going to twist this together. Now this hasn't, I've not seen this on any books, anywhere. I've never seen anybody demonstrate this or whatever, because I guess nobody ever had the need. But I did. So I wrapped it into 2, exactly lined it up, and all the curves, look at the curves. Really neat curves. See how I got that lined up with the red line? See, in geometry you have to be very accurate. So the problem is that wouldn't fit in to the heart. So I don't have a big one, but there's a hole here, yeah. And this should come out to there, shouldn't it? I mean, you know, if I do this right. But that doesn't work. That's too big. So I had to do it 3 times. So I just go around to the red line here. And what happened is that when I got it around to the 3rd one, kind of hard to hold this. When I got it right around to the 3rd one, after, all the lines turned to triangles. What the heck is that? I didn't know where triangles came from. They're coming from cones. How do triangles incarnate? Like this. Well, my trouble is with that is it still wouldn't fit in a new one. Oh, I do it again. Run it again until it hits exactly 4 and turns all squares. They're all squares. This is impossible. Now you know where the square comes from. Okay, believe it or not, that one goes into histine. So there were 4 layers. Now what I'm doing is what he did. Cutting them off, right? I did the same thing he did, but the only problem is that I didn't get 8 or 7, I got 4. So now what? So if I twist this anymore, it gets too skinny. It is more skinny and skinny and forget it. That's not the idea. And I thought, well, okay, what am I going to do about that? What I did was, I used 2 of them. Oh, that's going to work out good for me if I use 2 of them. So, I don't know if I have another one to show. I do. So what I did is I took 2. I took 2 of these guys, same size. And what I did was, I glued them together. Like that. So I'll show you the glue. But I also put these lines on. I saw where these lines were, I saw how they went in here, and I did it just like that, just like the drawing. And this is the one that I came up with. So I had this, I saw this, you know, how this was going in here. Yeah? Well, I know that it was a cone. So what I did was I made this into a cone. Paper clip here. I hope I have enough paper clips. So I made this into a cone. Now this cone is the exact cone. Oh, I thought I had a cone here. I do. Here. This is the size of the circle when wrapped up 4 times. I know that I have the right size. This happens to be 26 degrees. 26 degrees. So what I did is I just wrapped this around here like this. You know, just like I did before. That's great. That's going to work out good. And I'm going to come to the middle where I glue it together. I taped it together. See there? See where it's taped? Right there? Okay, so I got to keep this consistent. Wrap this around until I get here. Now, I don't see a paper clip there, so I'll use the original one I had. I had an original one that I had put together. Here. No, I don't have one. It's going to be hard for me to hold this, but I'll do it. So I realized that if I turn this around like this, okay, I think it's better to show you this way. I'll start in the middle here. And I bring this one around into a cone. Like this. So there's 2 cones here. There's got to be 2 cones. There's got to make some kind of relationship. So I turn this around like this until it met the center of the other one. Getting there. I'm not having as much trouble as I usually do. Until I got to the midpoint. Now, I'm at the midpoint now. But I got 2 cones. So, okay, I said, okay, just cut this in half. Oh, thanks. Thanks a lot. I don't need a book writer with it.
We don't have any paper clips in this room.
Well, I'm having trouble here. So what they're saying in the book, one of the part researchers say that these 8 layers are 2 cones, and one is inside the other, like that. And I tried that. I tried to cut this off and put it inside there, and what happened was it just slipped right out. You know, myofibers are not going to slip out. They are interwoven in one massive muscle. It's fantastic muscle we have. So what I did was, I thought, how am I going to do that? How am I going how am I going to get this one to beat this one? And what I decided to do is I studied shells. And there's a left-hand and right-hand shell. I didn't know that. And when I studied it, I realized that what I need to do is just unwrap this one around here. Like that. And when I got to the very end here, I still have the other cone. That's at the end. I still have that cone. So there's two solutions to this, is that either I cut this off, or I get this off and wrap it around, now it's 8 layers, or I leave it there and indent this one into the left ventricle, the right ventricle. Now you have the right and the left ventricle. Because this one's very thin, and this is very heavy and thick. That's one solution. Or just cut it off and wrap it around, makes 8. This makes 7. Now what's interesting about this is that when I did it this way, I found out that if I start with the heart here, the fibers are running down, right? So if I unwrap this and cut one off, it's not as much. And then if I continue to unwrap it, oh boy, now it's getting more. It's not as much. And I continue to unwrap it, now it's going horizontal. Here's the middle part, it's going horizontal. That's one. And if I continue, it's starting to go up. Then it goes up and becomes exactly like the human heart myofibers. Yeah, that's what I said, right? There isn't anything in the books that shows anything like this. That these are two circles. Another balance between right and left integrated into one form that has the balance between the outside of the heart and the inside of the heart reversing. Okay. Myofiber architecture. The research. So anyway, I go through all of this and I find out that they say that the form, okay, of these muscle fibers takes on starting out and an ending at 60 degrees. Right here. Cleavage plane 60 degrees from one extreme to the other. This is 60 degrees. The form itself is 60 degrees because it's an octahedron, and an octahedron are all based on triangles 60 degrees. So that was really great. So let me go on here and show you this. Get rid of these guys. There's a reversal. And then we have this. This right here is the left ventricle. And this is showing, okay, the myofibers. This is the right ventricle. But this is the one I've been studying, is this one here. And so I wanted to know where that shape was. And here it is. Here's that shape. I had this way before I had this research. I had this shape. Because this shape, okay, Nami, you saw the one that goes inside. The inside shape. Let's see. Yeah, look at this. Okay. Now it goes up to the top. Can't see it, but you can come up here. But I also noticed that, you know, I had this is the same cone. So if I put this in here, right where this is, this goes completely around the outside. And all of these points touch. So from the outside of the heart to the inside of the heart is parallel. These are parallel. So here's this cone. Now, inside the heart, and you saw this cone is this guy wrapped around, okay, like this. And the reason I found out that the heart ends here, this is where it ends, nobody cut this off, this is where it ends, is because if you twist cones around enough and you don't have enough cut off, it gets all jammed up. It doesn't work. So inside the heart, there is a loop. And that loop looks like this. Here's the inside diameter, and then they'll have a shape like this, a base. And then the outside diameter is here. And it goes down to about here. So, it's like this. This comes out over here like this. Okay, so what they say is that there is a loop in the heart. And the loop looks like this. It starts out here at the periphery, and goes down across like this, it goes around here like this, and goes out into the inside. It's a loop. And that's exactly the way it looks, okay, in the drawings that you'll see in the heart research. That's where that loop is. Well, I want to know where that loop is in my form. And one of the puzzling things about everybody that gets this is how can you go from the inside of the heart and run a loop through and get to the outside? The reversal, the balancing. Okay, so I took this form and I found that loop. There it is. It's the same. There's the loop. Now, if it's going from the outside, or from the inside to the outside, then, if this is true, then I know where this loop is in every one of these sections. So there are 8 sections. I know exactly where that loop is in every section, because the geometry showed me that. Or in all the heart research, I've never found any of the heart people saying where that loop was and at a particular myofiber there. So this is, well, I want to know where it comes from. I want to know where this thing comes from, this loop. Now you know that I have 2 circles. So there's the loop, and I'll show you where the loop comes from. There it is in every layer. Beautiful. Sculptors like this. So, I also want to know what this is going on here. So, if I take this and put this into I need a flat table to use it, but I'm going to flatten this out into this shape. So I can get it accurate into this shape. Takes a while. The plastic is really flexible, so it twists a lot on me, but I get it. There's the first one, right? And I'll take the other one, which is going in the opposite direction. That's really interesting. And if I put it together, I put the 2 together, yeah, that loop is at group 3. Now that's amazing, because also that's the balance between the one turning left, one turning right. The geometry is showing that. This isn't seen anywhere. This is a tool. This is backing up everything that these research papers say. There are 50 research papers here, and I haven't found one to disagree with me. This is not trying to compete with them, it's trying a new tool. That's a new way of looking at the geometry, the scaffolding that's there that you don't see. Alright, so that was another discovery that I hit. And here's the loop. Yeah. And that's right off the medical books. So what that is, you know, they don't say what this is, but you don't realize it, but this is just a cone. That's why it works like that, because here it is. Here's the outside of the heart, and here's the inside, right? So you start here, right? And you start the loop there, and you just do this. And now it's on the outside. That's simple. Now, here comes a big deal. Vortex suction. This is the microvalve opening dissociation. This is out of the twisting and rapid filling and vortex suction. This is a big deal of my work that explains things that haven't been explained. And basically what I found here in these research papers is that the ventricle, the inside architecture of the left ventricle at the very end says, we do not know the nature, and it is unclear to us why this happens. Research papers. And this is the dissociation of, wait a minute, here's another one. It says, there's so many, I don't know where to start. But this one, well, this other one also says, it says that we do not understand this movement. Okay, that's fine. You know, neither do I. But if I go back to this, okay, this is the outside and inside of the geometry. I made this form. And here it is. I made it in like this. Now what it's saying is that the base of the heart, okay, and the apex of the heart turn in the same direction, but the mid-level turns in the opposite direction. No explanation for this at all. They did not know the answer. So what happens is that these turn together, okay, but when this starts to move, now if I turn this clockwise, this is going clockwise. They're saying this one goes anti-clockwise, and sure enough, it does. You can see how they turn in opposite directions? This is why it works. This is what's happening in the left ventricle architecture that they don't understand. Because they don't have the geometry to know how you can have the mid-layer of the heart and the base of the heart turn in opposite directions. So it's like this. Okay, they say that this starts to turn clockwise, like this starts counterclockwise. And then it says that this part is contracted, and then this part in rapid filling, this is going to fill now. This is contracted. Blood's gone out. It's contracted. Here it was like this. It's contracted. Blood has gone out. Then they say the base turned this direction, but then the apex and the mid layer turn the opposite direction. Well, here it does. Well, here it is, here it is, contracting, okay, expanding. Opposite directions. And they explain this procedure exactly in these research papers, that this is exactly what's going on. Now we know why. We know why the geometry does this. Because, of course, this one is this form. Edges only. Now what happens to be able to get that to twist in opposite directions, I had to remove 3 edges. And what happened is those 3 edges are like tendons. They're flexible. These are pretty stiff. These guys here are strong. And so what I did is I found out that the heart, of course the heart is never empty, 40 to 50% filled all the time. When the heart is completely empty, it looks like this, just like this one that I just showed you here. Nothing in the heart. See the twisting already? See, there's no twisting here. It's already twisting. So if I put 50% of the blood in here, in the form, it looks like this. And this part is stiff. This part is flexible. So if you look at the heart, it's flat on this side, but this part loops out. All right, let's see if I can catch this up here. All right, this one shows that there's this loop goes on here, and then this one is a real heart. And you can see that there's that loop. And really, if you look at it close, you know, they don't understand why there's this little one here and why this one goes in like that. This shows why it does. And also, if you look at this, if you could look at this in a better picture than this thing is blown up, you will see there's a line here. There's an edge. It's very faint, but the geometry is still there in this part, where this part is totally flexible. Makes a beautiful S shape. And I did this is all very accurate. This is shows them together. You even see this. Look at this. You have this curve here. This is original geometry. You have this indentation, and then it goes out, and it goes out, and then it goes in here. So the geometry is actually showing, okay, a heart, okay, that is half full in the ventricle. And of course, when it's completely filled, it looks like this. These are the different stages. So if I do this, empty, half full, and full. Now, suction. The heart has a rapid filling. And this heart fills up, okay, and about a third of a second it's filled, like that. And there is not really a clear-cut explanation of how that happens. You don't really know how can the heart fill that way. Okay. What is happening here, according to this research, okay, is that we have what we call, what they call, a disassociation of time of the left ventricle architecture, the internal, a disassociation of time. And what that means is that the mitral valve and the aorta valve are closed, okay, at the same time, while this turns 20 degrees. So from here to here, both valves are closed. And then, at this point, the rest of the 50%, okay, then the valves open. Now, what actually is what happens here, and then this goes down. Rapid filling. So the rapid filling, okay, is caused by a suction. It's not being pumped into the heart, it's being sucked in, according to this research. And what happens is that if you take a volume and decrease it in size without opening anything, this is what happens. I use that book here. I take a suction cup, a regular suction cup, and I put it on here and I press it down. Okay? I can't get it up. You know, I'm a terrorist cover, I know I've tried. Okay, so the rapid filling is because the blood is being sucked in, not pushed in, not by pressure. So, without those valves opening, you create a downward force on the suction. And then when you open it up, the suction just goes. I know it's a simplistic way of saying this, but this is a suctional form of architecture that is leading to rapid filling. So in this process, I studied congestive heart failure. Based on congestive heart failure, which is a major problem in the United States, okay, is that the heart is taking on a different form. And the one form that they say is where it is, this is how they describe the shape. A congestive heart shape looks like a basketball. And this one here, it says it looks like a sphere. They don't know it's an expanded tetrahedron. They don't know the geometry. And they call that the mid one, they call it the healthy heart, they call it gothic. They don't know that's the Chestahedron. And then the constrictive one, they call it the giraffe heart. And that's because it's so constricted. They call it what? They call it a giraffe heart. And they use a giraffe, and the reason they do that is because the form is so constricted. Here's the constricted one compared to the normal heart. We call this a giraffe heart because the giraffe has to pump the blood all the way up the neck. So it has this type of configuration where the normal one has, like this. And this is the shape of congestive heart failure. This is the geometry of the interior of the architecture of the left ventricle, okay, when the heart takes the shape of a tetrahedron or a basketball. They call the normal heart a football. And they need some better terms. And so what is happening here is that in congestive heart failure, there's very little suction. And sometimes there's hardly any movement, so they both turn in the same direction. Instead of the opposite direction, both the base and the mid-level are turning in the same direction, okay? Whereas in a normal heart, they're turning in opposite directions. So congestive heart failure has to do with suction, because the architecture has changed itself to look like a basketball or a bowed-out tetrahedron. Okay? This is congestive heart failure as far as geometry is concerned, because this part here has hardly any suction. Now remember that this is just a tool. This isn't trying to replace anything or to say something's wrong. It's something else to look at. Why the congestive heart failure is going on, why there's no suction, why there is less suction, and why it is called congestive, because the blood is being kind of blocked, held in one place. So here is congestive heart failure. And this is the normal heart. And this constricted heart. And here are the shapes that show that geometry. I'm setting this up so you can come up and look at these things. I had to borrow a rice cooker measuring cup. Okay. So disassociation in time allows suction to develop. That's why both valves are closed at the same time. And it's basically the rapid filling is coming through suction based on that form having both valves closed and compressing. And then when the valve opens, boom, it just puts that blood running. Now what's interesting is it doesn't get down to the bottom. Because why? Because the bottom is a tetrahedron. And the bottom, okay, has nothing to do with suction. If anything, this is a brake, it slows it down, so this isn't so fast. But I'll tell you what, that one in the middle, which is the tetrahedron, is really an active source. This is the active part of it. Now what they try to do is, the research says that they try to get the basketball to a football. And they do, one of the ways they do that is they run a stainless steel rod through the heart, and then put two kind of washers like and squeeze it together to try to get the heart back into the Chestahedron shape. The problem is that those spikes are going right through the vortex where the suction is supposed to be going on. But they don't know that. They're trying to get it back. And I don't blame them. Probably I do the same. I didn't know. They also put nets around it to try to squeeze it back to the Chestahedron. They also try to put a net inside this one to expand it. Okay, so the problem is they don't realize, okay, or maybe some do, that the suction is going on between the base and the mid-level. Okay, congestive heart failure. This is the congestive one. This is the normal one. This is the giraffe. Here they are. We call this the sphere, that's called Romanesque, or basketball. We call this one a football, or Gothic. And this is the giraffe. This is right off the research paper. Okay, and so here's what's happening. The congested heart failure, both the base and the apex are turning in the same direction. When the normal heart, they reverse. Now you know why. Because this guy here, okay, doesn't turn in opposite directions because it's lost its suction capacity. It's lost its geometry. It's lost its healthy shape. And they don't know why this. They just know this happens. This is a phenomenon, but they don't know what's behind the phenomenon. I don't know if it's going to help them or not, but it's what I found. Oh, here we go. The fifth chamber. Rosestanner talks about there's a fifth chamber that will develop in our heart in the future. Okay, so it's supposed to carry moral forces and develop those forces, okay, for the future. And there is no explanation of what it looks like from him or anyone else. The only thing we know is that the beasts have a fifth chamber. So, how can I figure out anything to do with the fifth chamber with this? Okay, so we have a chamber here, out and in. So that's a 1, and then I have the atrium on this side, atrium on this side, and here there's 4. So what I found out was that as you saw, this one twists 40 degrees, like this. I have the research, I think, on here on my computer that shows how much the inside heart twists. It twists like that, about 40 degrees, like that, and goes back, opens up. There's the original shape, huh? Of the tetrahedron and octahedron, or tetrahedron and octahedron. Here it is, 40 degrees, it's about right there. Now, if I allow this to turn 5 degrees more, there's a new chamber right there that's completely locked off from the rest of the heart. It even has almost like a tricuspid valve at the top, and it looks like that. And then it opens up. It's gone. The fifth chamber, okay, and this particular example, the only one I've seen, that a possibility of the fifth chamber is that you can't see it. It's not there. But it is there because if the heart allows the inside to turn 5 more degrees, there it is. So of course, as a sculptor, I will make that form. So here's this one. This shows what I'm saying here, that this turns 40 degrees. Here's how it turns. Oops. It turns 40 degrees. So at the top, okay, you can see basically the outside doesn't change. It twists a little bit, but not much. Basically pumping like this, kind of. But the inside one turns 40 degrees. So it turns like this, 40 degrees. Now what's really interesting is that the heart has a rhythm of less than 1 second that it goes through its motions, okay, moving the blood in and out. And in that 1 second, okay, when it gets to this point at 40 degrees, it's 0.36 seconds. There's the 36 again. And this is what the sculptor makes of the fifth chamber. This is what it would look like. Well, it's used up almost 2 hours. And no one left. Only one person. That's all right. So you have any questions or whatever, that's kind of where I wanted to end with the fifth chamber, because it's the most mysterious, and the part that will develop in our human heart, according to Rudolf Steiner, at a certain stage, and this is supposed to have repercussions to the human being as a human being that Pfeiffer in his heart lectures talks about. Because he would ride with Rudolf Steiner. Wherever Rudolf Steiner would go, Pfeiffer would go with him. So he wrote the heart lectures and so forth. Okay. Question, yes. Steph, would you come up here and help me with these questions? One, to help me understand them, and also, if I don't hear them, and also it helps other people in the back to understand what the question. So, yes.
Do you see any shift or movement from the 40 from the 40 degrees to the 45? Like, is there a slow movement process happening, or?
Well, no one knows.
You don't see anything like that?
Well, okay. Something is going to happen in the human heart that allows the left ventricle architecture to twist a line.
Okay.
It's a vortex. So what I see out of this in the geometry of that 5 degrees, approximately 5 degrees, will be different in everybody, is that I think that we as human beings do two things. We have to become balanced. We have to be balanced, we have to balance our life, and we have to be more open in our life. Okay, open. Now that doesn't mean that we're going to be hippies. That's not the idea. The idea is to have a balance, okay, between opening and closing, and being able to have the flexibility and the freedom in our lives. Don't get stuck in polarities, Democrats and Republicans, or this or that. I mean, those are very dangerous for the heart. Heart doesn't like it. The heart is all about balancing polarities. It's not getting stuck in one. So the more that we get away from being stuck, and the more freedom that we have, which will come from that, I think that the heart will be loosened up in such a way that this will happen.
It's a loosening.
This is what I think will happen.
Do polarities cause the congestive heart failure? Is that doing the basketball, or what did you call it?
Well, certainly a possibility, I'll tell you that. It's certainly a possibility.
Okay, so
Being stuck means that it's lack of movement. That's what the congestive heart failure is all about, is that the heart, the blood is just, there, and it's getting stuck, and so bigger, and whatever. Of course that's a polarity problem.
Okay. Thank you very much for your lecture. I really enjoyed it. But the question I want to ask is, you've come to this through geometry, and that's wonderful. But because you're dealing with a moving object, one that has these pulsations, have you investigated the relationship between this and sound and resonance and even things like cymatics and that kind of thing?
I only have so much time.
I recognize
I
that.
spend all the time on this. Okay. And of course there's a connection. And this is why I give lectures, I'm hoping that somebody will take that up. I can't do it. I just don't have, you can't believe all the stuff I have that I didn't bring, and all the stuff that I'm doing. You know what I mean? Here's the thing. Here's the thing. I have to do, and the amount of time I have left, I have to do what I'm good at. I have to do what basically other people can't do. I got to do that. Okay. Somebody else has an interest in music or sound or vibrations or resonance or sympathetic vibrations. Okay. Go for it, man. Go for it. I just don't have that much time left. So I have to do what I'm really good at. And I'm good at this.
Yeah, I can see that you're
So, can you help us maybe conceptualize this a little bit better? This is a physiological space between the left and the right atrium and the base of the heart.
No, this has nothing to do with the atrium. The atrium is way up here.
Okay.
This has to do with the ventricle architecture of the left ventricle, which is what receives the blood from the lungs. And so this is etherized blood. This is the blood that's full of energy. Okay, it's full of all the vitality and life force. Because it's the red blood, and this red blood, okay, is being, of course, it's being sucked, okay, down into it, and then it's being taken out. But between going in and going out, this may happen. And if this is anything, this is gleaming the etheric that goes, now see, I'm talking about stuff I don't know about, okay? I'm speculating. I don't like to do that because I like to have things that I can show you that you can follow and have confidence that what I'm saying has a lawfulness. If you just go by a belief, well, I believe this and I believe it that, the problem with that is that that will lead to doubt. And we don't need doubt. We don't need doubt in our life. Often we need the opposite kind of to work with doubt.
But the thing is, you're talking about here, this is, your journey is kind of like Close Encounters of the Seventh Kind. You know what I mean? There's this, like the guy that worked with the mashed potatoes to make the, whatever that thing was.
I saw that.
You know, it's like, there's something that's, there's a desire or a drive or a yearning for some understanding that out of that system, belief or whatever you want to call it, you're driven then to find the facts that back it up. And yet, there's a real value in, you just spent 2 hours giving us this wonderful lecture. We're allowed to have a few minutes of speculation.
Yeah, I understand. I like to be speculative. I like to be subjective once in a while because I am a subject. You know. So I can be subjective once in a while, but I like to have most of what I show you that can be done by you. If you want to take my stuff, you can take any cube, take Chestahedron and do exactly what I did, and you're going to have the same results. But if you ask me about what's going on here, and then you ask all the other people here, it's going to be all different subjective answers. So my subjective answer to this is, if you don't mind, is that I feel there's a gleaming. If you take a rag and you put it in water, a towel, and you twist it like this, which is what the heart does. The doctors call this ringing. It's wonderful because it's a bell and it's also ringing out. So when you squeeze it, do it at home. Go home and washcloth in the water and then squeeze it out and watch it. And as you start to squeeze it, just before the water starts coming out, you see all this movement around the surface, little tiny things. That's the etheric that I see coming out of this that will collect and go up to the pineal, pituitary, and become the new human being.
Yes, you have been talking about geometric spatial form. And in the last graph you showed us, you had the x-axis, I believe, related to time. How does time enter into this equation that might lead to the fifth chamber?
Well, we're headed for it.
I mean, does that mean that the rhythm of the heart will change in order to achieve that? Or is it something else? I mean, what was the significance of there being a time axis there?
Well, you know, I'm a geometrist. I'm not a doctor. I have nothing to do with that. It's not my interest. I just got, listen, there's other things I've got to show you besides art, behind the heart. It just happens to be something that I got involved in for a couple of years. So I'm not really an expert on a lot of these things. I just know the geometry that maybe could be used by art researchers, whoever, or not at all. Doesn't matter to me because this is objective. Whether people like it or don't like it or find something to do with it, doesn't matter to me. I'm not attached to this. I'm only attached to bring what I've found about this form. And what I found about it in the earth, and what I found about it in other things in water. Found unbelievable things that this does in water. That's what I do. So if someone doesn't take it, it's okay. And if you go on here and think, that is the biggest bunch of bull I ever heard, it doesn't bother me. That's okay. I'm still going to go back and work.
Thank you, Dan. Have you found any correspondences with your geometry to the location of the septum of the heart or the valves of the heart? Do you have any specific locations?
Like the intraventricular septum? The intraventricular septum?
I can.
The intraventricular septum. Is there a relationship in the fifth chamber in that area of the heart?
Okay, I did study the valves and I did study the size geometrically.
Yeah.
Okay, and I can show you geometrically why they are that size. So that's all I can do. I can't do any more than that. Sorry, I
amazing.
wish I
You
could
can
give
do
you
that.
these things, but this is it, if you know what I mean.
So because I know that we're created
Come and help me here with this stuff. I don't know if I can hear it, and I want to hear better.
So because we are created according to the golden ratio, I'm kind of looking for that connection or something, and I don't have to have that, but I just wondered if there's anything you would say about that.
What's the connection between your forms and the golden ratio, particularly with the heart? If there is any.
This form is based on a pentagram. This is an infolding pentagram that comes down to meet the tetrahedron that's opening up. And the pentagram is nothing but the golden proportion. Absolutely nothing but it. So absolutely, yes. That's all to do with golden mean. Glad to tell you. Yes, sure.
Earlier, did I hear you say that the bees have a fifth
Yeah.
chamber? Have you considered studying the geometry of the bees part?
No, I don't know about that.
The bees in Mars have a fifth chamber, or is it? The heart does.
See, it's the only one place that the fifth chamber has been found in the heart is the bee.
When you talk about the changing of directions and pathology, I just wonder, I don't know if it can be answered, is, I mean, as a nurse practitioner, I wonder what's the turning point for the change of movement from one to the other.
You mean between a healthy and an unhealthy heart?
What occurs that eventually, all of a sudden, the direction goes a different way?
You mean constantly in the human heart, these things changing, or the development of a disease or a problem? In between that?
I think what Julie's saying is, that what you explained was that you have a healthy heart and the base and the apex are going in a different direction, but that in the diseased heart, they both start going in the same direction.
Yeah.
And her question was, what is the physical...
Or just the phenomena, what occurs that all of a sudden that turning point
Is
goes a direction?
it just that the connecting geometry breaks down and so you don't have that happening? Or what's going on that causes the change in direction?
Well, someone kind of asked that question before, and I said it was out of balance in the polarity. There's some kind of polarity in your life that you're stuck with, okay? I think that's all I can say. Congestive heart failure, I mean, I just know a little bit about the geometry, that's about all. But as far as effects and, what happens and so forth, better people to ask.
Just in terms of the geometry that you're showing us, it looks to me like the congestive part has more contractive qualities to it than it's opposite.
Yeah, I mean, what's interesting about the geometry that I'll tell you about contractions that you mentioned is that the physical side is the tetrahedron is being contracted, okay, into this form of a chestahedron. The reason they call it the chestahedron because this is an object that's found in the chest. It just so happens to have something to do with my name. But, I have to apologize for that, but you have to remember they have to look at your name because my father worked on the first heart-lung machine ever invented that was used for operations. He worked on that. His name was Frank Chester. And my grandfather, okay, I don't know what he did, but his name was Frank Chester. Okay, so I don't know. I mean, I could have said my name, I named the chest of drawers. But it's just, I just thought that this is an organ, that this is the geometry is found in the human being. Okay, it's not a tetrahedron, it's not a icosahedron or whatever. This is an organ. And what is an organ? It's an organization.
I may have missed something when you were talking about
Yes.
Did you say any more about that?
Well,
In the image that you had, I wonder if we could go back and look at that. And I don't know if it was just to recall if it was an artist's rendering, how the lines, they formed images for me, and I don't know if it's just me or what was there. Yeah. So
okay.
there's almost to me like a little guardian down at the top. Yes.
Well, to me, these are, the myofibers are in this area, and not here. And so this is kind of a loose mass, right? Okay. And this part in here is deaccelerating. That's a deaccelerating shape that's deaccelerating twice as this shape. So this part right here is slowing down. Okay. So where that comes in, at the very bottom, the geometry is agreeing that it's paper thin. This doesn't balloon out. So if this was a pump, see, I never said, you know, I don't go around giving lectures that the heart's not a pump, you know. I'll let somebody else do that. I'm just telling you what I see. But let's say that it is a pump. Okay. That means that this thing here is the geometry, and it's pumping the blood throughout the whole system. Okay, above the blood above and the blood below. And if it's pumping like that, and you realize how much has to, and so many doctors are talking about how many miles it is and what the pressure would be. This would blow right out. This would pop right out. It'd be gone because there's nothing there. So this is, as far as this form, this is not a pump because this would just gone. Now that's one thing that a heart person is saying that the heart is not a pump can actually point to, that this here, right here, would not be indicating a pump. At one point.
Maybe to add to that, in terms of the vortexes, if you take, if you just take some liquid in a thing and you squeeze it, then it's a really chaotic situation. The liquid will just go at the least, the area of least resistance. But if it's organized in a vortex, then it's structured. It has intrinsic form, and that form, then because it has something intrinsic to it, can be manipulated. So you can take a vortex, you could take Frank's vortex generator, put the other form in there, and the vortex modifies itself based on the conditions. But it doesn't just disintegrate completely unless it gets too out of balance. So you can take a vortex and you can manipulate the vortex. You can direct it, you can change it. And if you look at the heart in terms of the twisting motion of the way the heart in the chest is not just squeezing, but it's twisting at the same time as it's compressing at the base where it pumps the blood out. You can think of it as a way to organize the vortex rather than just like, okay, squeeze, go out, then close the valve, pressure builds, open the valve, squeeze, go out. But as an organizer of vortices, and I'm trying to remember, but there's a, if you, in your blood, right, your blood has many components, plasma and platelets and all this stuff. So some of it is very just liquid, and some of it is more like little balls of, right, your cells carrying the iron going through, and you need to get that to the farthest place in your body, right? Well, if you look at the heart and you have the aorta coming out, if it was just a pump, it would be a really poor design to, at the place of highest pressure, immediately turn the pipe like this. It would be not a very good design. But if the blood is organized in a spinning vortex, then you have, just like, down in like your bathtub or something, if you drop a ping pong ball that floats, it goes around, but where does it tend towards? It tends towards the center. And if you spin your tea in the drink, you can see how matter organizes itself when it's in a spinning context. So that as a possible way to look at the way the vortices help the blood flow, the denser parts of the blood then would tend towards the center of the aorta and be able to move through where the plasma and the more liquidy parts on the outside are creating the higher pressure on the outside, lower pressure on the inside, therefore tending the more dense elements to go towards the center. So it's more like a, just like zooms right down the middle without having to, if you, bump up against the outside and get dragged back and have, less efficiency. So it's a very efficient way to organize flow. In fact, all flow is essentially vortexial flow. And straight flows are always deviations from the natural vortexial movement. So it makes a lot of sense that in the heart, it's about organizing the vortex. And if you think of a merry-go-round, spinning, you don't need to push the whole time, right? It's kind of like an organized form. You can just push rhythmically, and that keeps it going. You can sort of imagine the way the heart, it doesn't need to, pump the whole time, but it doesn't also just pump chaotically. It pumps just at the rhythm to keep the vortex flowing, spinning out through the aorta. And in that case, you don't need a lot of intense pressure. And if something goes wrong and there's a polarity and you start to lose the ability to have variability in your rhythm, then you need to start compensating. Maybe you need more muscle to squeeze more because the form, the geometry, is not as efficient. And so in that case, you can get like an enlarged heart or all of these other kinds of things. And I'm trying to think, there's one more aspect of that. Right, heart rate variability, right, is a measure of heart health. So the more easily your heart is able to change from one rhythm to another is an indication of how healthy your heart is. So a poor heart is one that can only do one type of rhythm, even though circumstances may require you to either relax or rev up, right? So heart rate variability being an important aspect of balance between going too far in one direction, too far in another. And that may have some relationship to the questions about the fifth chamber and polarity and balance and polarity in the forming of a new space. I don't know, speculation.
No, what he thank you very much. What he said, okay, is kind of what I've been trying to say. So, very important to have the balancing of polarities, which that's talked about. And so let me show you one other thing that's simple, okay, which is kind of my work about a vortex generator. Okay, so this will reinforce what Sept had to say. I don't know where the eraser are, so I won't draw. But anyway, the vortex generator looks like this. And when the vortex comes in, okay, it's like this. Bigger, bigger, bigger. When I put this form in, okay, so it looks like this. And then it goes down about like that. Does that make sense?
The form goes down or the vortex?
The vortex. Yeah, the vortex right now is inside this form. See that? This is going around like this, okay? And it's going in this form, in this hole. It does. It does that. That's what it does. That's why I drew it like this, even though this is really, a triangle. Follow me? Okay, so I got this spinning like this, okay? And the vortex goes in here. Okay? The vortex, are really cones, goes in here, right? Goes in here. Goes all the way down to the apex right there. That's the geometry behind it. Now, this is what happens. When the vortex doesn't look like this, the vortex is more like this, isn't it? It isn't straight. What happens is once I get the machine running, the vortex will start here, and it'll go right in this circle. Goes in right in there, right in there. Yeah? And then when it gets down to about here, it touches the circle. So what happens is when this vortex gets bigger to that point, the spinning of this form, all of this goes out like this. The water just spurts out like that. It will not allow the vortex to go any deeper because this circle prevents it. The vortex could get bigger and bigger, but that circle right there restricts the vortex right here. And this vortex can't get down to the apex. It can't get down there. It won't go down because of this.
So where in that diagram would the fifth ventricle?
Right here. The
Fifth chamber.
yeah, and the fifth chamber is. Let me show it. The fifth chamber is from about here, at the mid-level, to the apex. Right here. So it's in this area, in blue, being constricted, twisting in. So the apex is in the bottom half of the heart, not in the upper part. The upper part is suction.
My question is about the form that you create from going from the outside of one cone to the inside of another. And and there's something in my mind that I don't understand. I'm trying to keep relating it to root 3 and the best of Pisces. And I noticed when you drew the 2 circles, that line you showed in the proof was root 3. And I'm just kind of wondering if there is any relationship between root 3 in the planar geometry and the dynamic of the form that you're creating when you drew from the outside of one of those circles to the inside of another.
Yes. The question is about the 2 cones, and when you take the 2 circles, roll them up, and get the loop around from the outside to the inside, and its relationship to root 3. And your question was, what is the relationship?
I'm just struck by that outside to inside form. You know, we have limnoscapes, we have many different patterns, the flow form pattern, there's many different patterns that engender life. And I haven't seen that one where it's a concentric circle that is lawful, that has a certain principle and property to it. And I don't know, this is where I don't know, right, I'm questioning, does it have any relationship to the original planar geometry of the root 3?
If you take the cone, right, that's the root 3,
Yeah.
and you roll this up,
Yeah.
right? That's where you get the cone that goes on the outside and on the inside,
Right.
and that root 3 line traces the same form as the loop.
That was beautiful, so elegant, and that's why I love the lawfulness. But for me, it's actually this shape. It's not a spiral shape, it's not a vortex shape, it's actually the dance, like almost like maybe the D-waggle dance. You know, what is that form as you're going from the outside of one cone to the inner? Does it have a name? Do you see it in many places?
I see the actual 3-dimensional loop
and
itself.
when you look at the model, the sculpture of the shape at the top and the construction at the bottom, does that curve happen, you know, at the bottom? I'm trying to understand how they relate.
Okay, she wants to know about the loop. What does she want to know?
Hold it up for her so she can see it go this way.
This one?
Yeah.
I can draw it for you, that's going to be hard to do. Okay, so here it is here.
Well, here's what sure. Is your question what this shape 3-dimensionally, like what is this shape? Is it found elsewhere? Does it have?
John has something. Okay.
Yeah.
So for me, it's like that form. You know, we see in flow form, we see a different form. We see all kinds of forms that repeat in nature. Okay, so what is about the form that you've drawn that does it have a name? Do you see it other places? How does that happen?
Whether you describe it as a spiral or less.
It's a part of the spiral.
Now, all the research tells you where these are found. They're all on the internet. I only chose ones that are free. Bottom page 4, this talks about the loop. Let's see where the loop is.
Is there a name for the loop?
And it talks about the research of the loop.
I don't think there's.
There's a lot of things being done with this loop. And a lot of people are saying it has to do with the distortion of the heart and the way it moves from right to left or whatever. To me, the loop it prevents the heart from being overstretched. It's trying to keep the heart in its original configuration. So if the heart expands too much, okay, or contracts too much, that affects the loop, and I think the loop is trying to help along with the amount of fibers. I don't think it has anything to do with the way that the blood is moving in and out. Remember that the heart is after the blood. The blood comes first. The baby's blood is going around out the mother's blood, and it's going like mad, and it's going all the way around. Has no heart. And only once it comes in, after a while, I don't know how many weeks it comes in, and then what does the heart do? It breaks the blood. It slows it down. The heart is not a pump, it's a brake. It's a deaccelerating organ. And that loop right there helps to deaccelerate so it doesn't get too fast, doesn't get too wild.
So if we don't leave, we'll still be here when we get back. So we're supposed to have a lunch, be back by 2 o'clock, so maybe we can save the rest of our enthusiasm for the afternoon.
At 2 o'clock I'll show you an Egyptian mystery, and I'll also show you, I will talk about how to do this research, how to do what I did without junk, how to do it with films, how to do it with books, okay? How to do it with track and field.
Basically, the forces,
That's what I think. I agree with that. That's what it is. That's a Route 3. The movie said Route 3. Route 3 tells it. Wow. That's good thinking.